Assalamualaikum. My name is Muhammad Azram bin Syari, and today I'm going to present about my FYP final year project. My title is a design and analyze of micro hydro turbine with different number of blade. Firstly is the introduction. Okay, the problem statement is the function of the number of blade. Second is design of turbine with number of blade, and third one is the last one, number of torque in different of blade. Okay, next is a objective. Objective is to analyze the parameter of the function of the number of blade that influence the turbine and efficiency. The second one is to propose the design of turbine with the number of blade. Lastly is to estimate the value of torque with different number of blade using modeling application. Okay, next is a literature review. There are several in a literature review. The first one is a type of hydro turbine. Okay, the type of hydro turbine is divided by two. The first one is a impulse turbine, and the impulse turbine is divided by three. The first one is Pelton wheel, turbo wheel, jackrabbit turbine, and cross flow. The second one is a reaction turbine. This one divided by four. The first is propeller turbine, and propeller turbine was divided by three. Bulb turbine, straw flow turbine, tube turbine. Next is a couplant turbine. Under couplant turbine have a propeller turbine. It's the same, but actually not. Okay. The another two is a Francis turbine and kinetic turbine. Next is a main component propeller turbine. There I have a scroll casing and steering, guide apparatus, covers, runners, runner blade servo motor, regulator mechanism of the runner blade, cooperation mechanism of the runner blade, turbine shaft, turbine bearing shaft sleeve and seal box, runner chamber, draft tube, axial flow machine. Next is a characteristic of calculation. Okay, for the Q it was for diameter of a runner and hub. For P, power, N is a speed of blade, and S is specific blade, and the lastly is a flow rate. Okay, next we move to the methodology. Okay, this methodology is a four phase. The first one is a project planning. The project planning is most significant part to build up the task, since including the entire procedure from the undertaking title until the end. The title of project is speaking after a conversation with the supervisor, also the problem statement, objective, and the scope of project. Okay, the phase 2 is a project research. In the project research, the exploration of the task to be created is done at this stage, and the product to be used in this project has been considered. It will make it easier to work on this software by following these lines, because the understanding of the software has been studied. In addition, the book, thesis, and journal are used during the study to get the data to build up this project. Okay, next is the phase 3, project development. Project development, we are using a SolidWorks software to design the blade and the turbine. Okay, first is a propeller turbine. We are choosing the propeller turbine and the flow parameter detail calculation. Say like we got the power is 50.8 kilowatt. The blade speed we got the 1.09 rpm, and the diameter of runner is 0.89. The flow rate we got 18.7, and lastly the specific speed we got the 1196 rpm. Okay, the design of blade, as you can see here, the top of it is the turbine, and the second one the blade, and the lastly is a fully complete for the turbine, micro hydro turbine with blade. Okay, next is the design of blade. So as you can see, I choose this. I draw three kind of blade. So the first one is a 4 blade, and the second one is a 5 blade, and the lastly is a 6 blade. Okay, for the last phase is phase 4, project design and analysis. Project design analysis, as you can see, the left side is a first in beginning of for the CFX simulation, and then this right one is for the meshing, and the lastly the data actually for the meshing point. We are using 100 meshing point to get this one. Okay, move to the result and discussion. Okay, the result was obtained from the 2.6 meter inlet and 3.5 outlet, and diameter of runner of blade is 1 meter. The inlet velocity was keyed in the software is a 3 millisecond -1. This is analysis of the data. As you can see, here is the result for velocity of contour. 4 blade, 5 blade, and 6 blade. For 4 blade, we got 4.126 meter per second. For the 5 blade, we got 3.91, and the 6 blade, we got 4.057 meter per second. As you can see, there are three different of the number we got. This is the data of torque. The data of torque, this is the result we got. So I put it in the graph. So the torque for 4 blade, I got the 40 joules. For 5 blade, I got 20 joules. And for 6 blade, I got 6 joule. Okay, for the result and discussion, this is the result of the outcome. Sorry. This is the result of the research we received from micro hydro turbine with different blade number from NC software. We conclude after analysis that the velocity of 6 blade was higher than 4 and 5. Oh, sorry. The torque of the 6 blade was higher than 4 and 5.
Okay, this is a simulation from software. So this is a velocity streamline and create animation for this one. Okay, as you can see, the water flow in from inlet, then goes to the outlet from the bottom.
Okay, next is conclusion. Okay, for the conclusion, this project measure the impact of the number of blade on the micro hydro turbine on the generate power. Since micro hydro turbine are used to generate power when attempting to build more efficiency micro hydro turbine, it might be useful to know what number of blade generate the most power. The objective of this project was to identify the number of blade for a micro hydro turbine that will generate the greatest amount of power. Finally, torque played an important role in this project to build effective micro hydro turbine. Okay, that's all from me. Thank you. Have a nice day.